Hi guys, well, welcome back to my channel. Hope you are doing well. Let's start today's topic. Permanent dipole, permanent dipole. In my last video, I've already explained about hydrogen bonding. Now, look at the permanent dipole and permanent dipole, which is also called PD-PD. Now, you know that I explained in my covalent bonding topic, we have a polar covalent compound. How can we choose whether the compound is polar or non-polar? Based on the difference in electronegativity. Suppose I have A and a B, two elements of a different element. And if there will be a difference in electronegativity, then the molecule is said to be polar. Like I have A and A, there will be no difference in electronegativity. Like chlorine molecule, oxygen molecule, and hydrogen molecule, nitrogen molecule, fluorine molecule, chlorine, fluorine, nitrogen, oxygen, yes, bromine, I2. The electronegativity difference is 0. Delta E, electronegativity difference is equals to 0. So such compounds are called nonpolar. But some compounds like, for example, HCl, A and B type, where electronegativity of hydrogen and chlorine are not same. There will be a difference in electronegativity. Like for example, I have HF, hydrides of 7th group element, HCl, HF, HBr, HI. So the difference in electronegativity, delta En, is not equals to 0, 100%. So such molecules are polar molecules and they have permanent dipole, permanent dipole. And I'm keep on telling you guys, this dipole-dipole interaction is a type of force between two molecules. So it is not a force, means it is not a type of bond like a covalent bond, ionic bond. It is not a bond, it is a type of interaction between two different molecules. If suppose I have HF or HCl, take the example of hydrogen chloride, HCl partial positive, partial negative, and one more HCl molecule, H and Cl minus. So that chlorine and hydrogen will interact each other. So this type of bond is called permanent dipole-dipole interaction. So in all the polar molecule, where the difference in electronegativity is not equals to 0, such molecules have PD-PD, permanent dipole, permanent dipole. So most of the students ask me a question, sir, all the polar molecules, they have PD-PD. Some polar molecule, they're polar, but they don't have a PD-PD. How can we check whether they have a PD-PD or induced dipole? First of all, did you get it? All the molecules of AB type, what does it mean, sir? These are two diatomic molecules like AB type, and there should be a difference in electronegativity, like delta En is not equals to 0, then such molecules have PD-PD interaction. Now check the polar molecule which has PD-PD or ID-ID. Let's check the polar molecule. Rather, I have to say polar compounds which has more than 3 elements or more than 2 elements. For example, look at that. We have BF3 and ammonia. Ammonia is a polar, and a BF3 is non-polar. So check all the polar molecules whether they have PD-PD or ID-ID. Let's check. We have two molecules like very close, like ammonia and BF3 or NF3 and BF3. Let's check. BF3, look at the NF3. NF3 and nitrogen trifluoride, and BF3, boron trifluoride. So look at that, NF3 and BF3. NF3 is polar, BF3 is non-polar. What is the criteria to check whether they are polar or non-polar? Here we have a dipole. We have to check the dipole, rather than the net dipole. Net dipole of compound. I've already explained, guys, about the net dipole, resulting dipole in my previous videos. Look at that. There is a net dipole, 100%. Check net dipole. So if there will be no net dipole, check dipole, no net dipole. Dipole cancel off. If there is a net dipole, the molecule is said to be polar. If there will be no net dipole, the molecule is said to be non-polar. So all the polar molecules have PD-PD interaction. So make a note, all polar molecules or compounds have what type of interaction? PD-PD, permanent dipole. I'm coming to non-polar. Molecule, guys. So PD-PD. So first of all, we have to check difference in electronegativity. If the difference in electronegativity is not equals to 0, then the molecule is said to be polar. If the molecule is polar, then it has PD-PD interaction. Permanent dipole. Like, for example, I have one more example. Like we have CO2 and which one is CO2 and carbon, which have, so, and we have, let's check water molecule, 2 lone pair is 100% polar and a PD-PD. How can I check? I will give you one more hint, guys. All the polar molecules have PD-PD interaction, and check the symmetry of the molecule. If the molecule has perfect symmetry, then it has no PD-PD interaction because there is no net dipole. And if the molecule has a lone pair, then it is a polar molecule and it has PD-PD. So you are confusing me. I will come back to this explanation. Okay. Now, so first of all, AB type and AA type. AB means difference in electronegativity. Difference in electronegativity is not equals to 0. Difference in electronegativity, delta E, difference in electronegativity is equals to 0. What type of force of attraction? What type of intermolecular force of attraction? PD-PD, guys. PD-PD. If there will be no PD-PD, what's the another type of intermolecular force of attraction, which is called induced dipole? I will explain you what is meant by the term induced dipole, ID. Another name of induced dipole, another name, van der Waals force of attraction, London forces, van der Waals, van der Waals force of attraction. Van der Waals force of attraction, WALS. Waals, van der Waals force of attraction. Yeah, ID. Now, if a molecule is polar molecule, polar, non-polar, all the polar molecules which are non-symmetrical, polar, non-symmetrical, non-symmetrical. Mostly polar molecules are non-symmetrical, like ammonia. Ammonia, you you can't cut the molecule into two equal half because there will be a net dipole. Polar, non-symmetrical, and presence of lone pair. What are the condition? They should, if a lone pair, if a molecule has a lone pair, then the molecule is polar, non-symmetrical, and presence of lone pair. Presence of lone pair. So instead of confusing which molecule is polar, which molecules has PD, which molecules are ID, I'm giving you generalized terms. Check the polar molecule. If it is a polar, then hopefully polar molecule followed by non-symmetrical shape, non-symmetrical shape or asymmetrical shape, polar, non-symmetrical shape, presence of lone pair. All they have PD. Non-polar molecule, non-polar, symmetrical. I will give you example, guys. Non-polar, symmetrical, non-polar molecule, symmetrical, no lone pair, non-polar, symmetrical, because net dipole cancel off, no lone pair absence, no lone pair, absence of lone pair. You can cut the molecule into equal half, symmetrical, no lone pair, then it has ID. All the molecule which are perfectly symmetrical, like we can start from tetrahedral molecule. Yeah, all the group 4 element having 4 monovalent atom, like tetrahedral molecule. Check the tetrahedral molecule. Okay, now check the tetrahedral molecule, guys. Can I rub that one? Okay, now look at the tetrahedral molecule. So what are my two condition? My two condition, I will write one more time. My two condition: polar molecule, presence of asymmetrical, no symmetry, presence of lone pair. They have PD. You can say without looking the molecule, means without drawing the shape and all this thing, check it's polar molecule or not. Yes, it is a polar molecule. Check it has symmetry or not. If there will be no symmetry, polar molecules are non-symmetrical. Polar molecule non-symmetrical and presence of lone pair. So they have PD. Simple. Let's start. So what are the condition? Let's start NH3, trigonal pyramidal. No. Let's start. Okay, this is polar. Okay, no worries. Trigonal pyramidal. I'm talking about the polar molecule with a lone pair. Polar molecule, polar. Okay, that's my condition. Next condition: asymmetrical, non-symmetric or non-symmetrical, asymmetrical, presence of lone pair present, lone pair of electron. So what type of intermolecular force of attraction? PD, guys. PD. All the fifth group element having 3 monovalent atoms, like NCl3, NF3, NBr3, Ni3, as long as central atom has a lone pair of electron. So non-symmetrical, polar non-symmetrical, PD. Now come to group 6 element, guys. Come to group 6 element. They have They have lone pair also. So group 6 elements, H2O, H2S, H2O, H2S, H2SE, H2TE. Look at that. Two lone pair, two lone pair, two lone pair, two lone pair. So if such molecules will come in the past paper or will come in the examination, I've seen this question in many past paper. If they will come in the examination, you can say you can do all these mean you can check whether they have whether they are polar or symmetrical molecule or PD. First of all, are they polar? Yes. What is the condition? Non-symmetrical. I can't cut the molecule into two equal half, guys, because of the presence of lone pair. So undoubtedly non-symmetrical, polar, 100% polar. They are polar, all are polar, they are polar, okay, they are polar. Non-symmetrical, second condition. First condition, yes, polar. Non-symmetrical, yes, non-symmetrical. I cannot cut the molecule into two equal half. Presence of lone pair, yes. So what type of intermolecular force of attraction they have? Blindly, PD, guys, PD. They have PD. They have PD. Now we have already done HCl, HF. So we have done HF. Difference in electronegativity is not equals to 0. So they are polar. Polar meaning unsymmetrical. We can't cut into two equal half. So unsymmetrical meaning PD. What type of intermolecular force of attraction? PD. And blindly, rest of the molecule which are symmetrical, absence of the lone pair, they have ID. Induced dipole. The dipole is not existing in the molecule, guys, but because of the oscillation, I will teach you, a dipole is created in that molecule. So that's why it is called induced. It caused by ID. Look at that. So any molecule which are polar molecule, non-symmetrical, presence of lone pair, what type of intermolecular force of attraction? PD. Sir, you are repeating. Yeah, that's good for you. Okay, PD. Now, all the symmetrical molecule. Okay, let's check the symmetrical molecule. All the symmetrical molecule, tetrahedral molecule, perfectly symmetrical. Tetrahedral molecule. Non-polar, sir? Yes, non-polar. Tetrahedral, like methane molecule. All the tetrahedral molecule. CCl4, tetrahedral molecule. Tetrahedral molecule. Tetrahedral molecules. Tetrahedral molecule examples. I have given so many examples. Please, you can see my previous videos for tetrahedral molecule. Like methane is a tetrahedral molecule, sir? Yes. CCl4 is a tetrahedral molecule? Yes. Carbon is a central atom. So central atom is from group 4, having 4 bonded pair of electron and a no lone pair. So what's the condition for induced dipole? Non-polar. First condition, non-polar. Yes, non-polar. Is there PD? Non-polar. Okay, non-polar. One condition is non-polar. Symmetrical. 100% tetrahedral, symmetrical. There will be no net dipole, symmetrical, no net dipole, no net dipole, absence of lone pair, obviously no lone pair. So what type of intermolecular force of attraction? ID, ID. Now after that we can't go to the trigonal pyramidal. Trigonal pyramidal molecules, they have lone pair of electron, so non-symmetrical, they have PD. Now after trigonal pyramidal we have like we have non-linear molecule. Check the non-linear molecule. I want to check the non-linear molecule. All the non-linear molecules like H2O, H2S, which has lone pair. So uh, it has PD. So after that we have trigonal trigonal planar, molecule like a BF3, boron trifluoride, perfectly symmetrical, 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 symmetrical. Non-polar condition, non-polar, symmetrical, no net dipole, yes. So ID. All trigonal planar molecule have ID, induced dipole. The dipole caused by, it has no permanent dipole. After that, trigonal bipyramidal molecule. Trigonal bipyramidal, okay. Trigonal bipyramidal, okay. Trigonal bipyramidal, PCl5, no lone pair, guys. Example, PCl5, symmetrical, yes, symmetrical. Non-polar, first condition, non-polar. Second condition, symmetrical. Presence of lone pair, no lone pair, no lone pair of electron. So what type of intermolecular force of attraction? ID. We have octahedral molecule. Let's do the octahedral molecule now. Like tetrahedral molecule, octahedral molecule. Example of octahedral molecule, SF6. Tetrahedral, octahedral molecule. Octahedral SF6 molecule. I'm going to draw here, guys. SF6 molecule, perfectly symmetrical. There will be no net dipole. So what are the information? Why this molecule has no PD? Like first of all, non-polar, SF6, non-polar, yes, non-polar, symmetrical, yes, symmetrical, no net dipole, all the dipole cancel off, no net dipole, non-polar, no lone pair, absence of lone pair, no LP, lone pair of the electron. So ID, induced dipole. So can I give you one more example? A square planar. like a octahedral square planar, easy one. Square planar, square planar, all these square planar molecule. So look at that. Uh, any molecule which are polar, having uh, a polar molecule without a lone pair, no net dipole, are having PD-PD interaction, permanent dipole, permanent dipole. So one more condition. The another condition is like that: non-polar, symmetrical, no lone pair, no net dipole. Then the molecule has induced dipole interaction. Guys, I want to stop my video here. Thanks for watching. I will come back with a new video. Bye.